Hi, my name is Andy Mallet, and this is Glimmer DSL for SWT tutorial number 8. So last time I went through hello text and I introduced data binding. Today I'm going to go through a more advanced example of data binding in the login sample. This is one of the more advanced samples, the elaborate samples. Those samples usually assimilate multiple concepts from Glimmer all at once instead of just focusing on one widget or one concept at a time. So let's launch this sample. There it is. It's just a login app. So I can enter my username and enter some password and then click login, and suddenly the username field and the password field are both disabled and the status is logged in. Notice how the login button is disabled as well because I'm already logged in. And then now if I want to log out, I just click the logout button and you can see it cleared the username and password, preparing for another login. So again, I can enter another name and log in again. So it says status logged in, and again, if I log out, status logged out. So how does this work? This might seem like a very tiny, simple app, but it's actually very sophisticated. It includes a lot of things that are going on in the background, like handling the disablement of the fields, handling the clearing of the fields, handling the enablement and disablement of the login and logout buttons, as well as setting the status. So let me keep this on the side and start looking into the code. Let's jump straight into the GUI first. So here's the login class, and it's got a body. And in the body, you can see there's a label for username. This is the first label, followed by a text widget. And then there's a label for password and a text widget for password, and then a label for status, and another label for the status value. And then after that, these are the two buttons, the login button and the logout button. So let's break it down bit by bit. Let's see how it exactly works. So you can see that the username text field is data bound bidirectionally for its text property into the username attribute on the presenter variable. So if I were to go up and check what presenter is basically a login presenter class instance. And again, if I were to go up even more, it's just a model, and it's got a username attribute, a password attribute, and a status attribute. So let's scroll back down and see how, okay, so the text is data bound to the presenter username. The enabled property, meaning whether that text field is enabled or not, is data bound to the presenter logged out attribute. So what that means is if I'm logged out, it'll be enabled. So right now it's enabled because I'm logged out, but if I type in, my username and password and I log in, now it's disabled. Notice how this piece of data binding configuration has an extra option, which is computed by, and it's saying computed by the status. What this means is the status of whether you logged in or logged out is what affects ultimately the logged out attribute. If I log out, it makes the status logged out, and that makes the logged out attribute return true. So then the fields are enabled again. And if we were to look at the on key pressed, basically it's saying when I, let's see, if I type in Andy, for example, and I hit enter, I press a key, and if the event key code is the carrier's return, meaning enter, it's going to set the focus on the password, and that's why it jumped into the password field. So now let's look at the password field. So you can see here, again, the text is data bound to the password attribute on the presenter, the same presenter. The enabled property is, again, also data bound to logged out on the presenter, and it's computed by the status attribute. So the reason we use computed by is because logged out, question mark, is not an attribute that we set directly. We don't set logged out. We set the status, and that automatically then computes the logged out attribute. And to show you what I mean, if I were to scroll back up to the model, which is a presenter model, meaning it's a model that is there solely for the support of the view, you can see that the logged out attribute is basically the inverse, or sorry, the opposite of logged in. And logged in is calculated from the status. So that means logged out and logged in are both dependent on the status. They're computed from the status, and they depend on whether the status value is logged in or something else. So if I were to go back here, if I were to type in the password and then hit enter, on carriage return, it's going to log in. Another way of logging in is actually I can just go to the login button that you can see over here and click on it. And if I click on it, it's going to trigger on widget selected. And again, it'll call login on the presenter. So if I were to click login, everything changes over here, and it's all because of the change caused by the login method over here. So let's go up again and look at the login method. So you'll see that login will basically say it's doing some validation at first, but then after the validation, it says status logged in. So it's changing the status to logged in. And as soon as the status changes to logged in, what happens is that the values of logged in and logged out change because they depend on status. And here we're configuring the logged out attribute to be computed by status. What that means is I want the enablement to get triggered when status changes. So I want a cascading of events. As soon as status changes, I want this will change the logged out attribute, which will then trigger the enabled attribute to have a different value, and then the fields will get disabled. So that's the benefit of saying computed by. If I didn't say computed by, then I'd have to go and update a logged out attribute directly. But to simplify the code and keep it dry, we don't have to update logged out directly. I can just configure logged out and logged in to be all dependent on status. And then here I just say they're computed by status, and when the status updates, the enabled attribute updates. So on key pressed is just doing the same thing as on widget selected, meaning if I were to enter a value here and then highlight this button by tabbing into it, I can hit enter if I want. That's another way of logging in. So I mean, there are multiple ways of logging in. That's just a user-friendly user interface. It's good to provide the users with multiple ways to log in. And then if we were to look at the logout button, so notice how login is enabled when you're logged out, but logout is enabled when you're logged in. So that's why when we're logged in, logout suddenly gets enabled. And again, thanks to Glimmer data binding features, it automatically will get enabled. You don't have to do anything. This is, by the way, unidirectional data binding for this one. Whereas what we saw on top was for the text property was bidirectional data binding, because I'm interacting with the GUI over here and typing something in. So that's me causing a change from the GUI to the model. Whereas when you have a unidirectional data binding, it's a change that's coming from the model into the GUI. So it's a unidirectional data binding. So notice how on logout, it'll actually trigger the logout method. So if I were to go back up and look at logout, what does it do? First, it clears the username. Next, it clears the password attribute. And then finally, it changes the status back to logged out. The interesting thing about this code is that the model code is completely clean and pure of any concepts that are related to the view. So login presenter is handling the logic of the presentation. However, it is not handling any logic relating to the view directly, in the sense that it knows about widgets and it knows about widget properties. It does not. It's actually completely decoupled because of the Glimmer data binding features. And this pattern is sometimes called model view presenter or model view model. It's basically this is completely isolated from the view, and we just data bind certain attributes to the view, And when we cause changes here in the model, they automatically will get reflected on in the view. So when I clear the username, clear the password, and change the status, so let's click log out to see what happens. Notice how immediately username got cleared, password got cleared, and the status got changed to logged out. So what that means is that Glimmer DSL for SWT enables writing very, very decoupled and clean desktop applications where the logic in the models is pure, object-oriented code that does not have to worry about low-level view details relating to widgets. And that's great because then I can make this model, if the model had more sophisticated logic, perhaps, that I'm worried about resulting in bugs in it, I can actually write like automated tests for it, like unit tests, for example. So all of that thanks to data binding and the MVP pattern in Glimmer DSL for SWT. So yeah, that about sums up what a more advanced usage of data binding in a Glimmer DSL for SWT app, sample app, as well as demonstrating computed data binding using the computed by option. If you want to learn more about the Glimmer DSL for SWT project, check out the GitHub link for the GitHub project.